Hey everybody. You might hear some music. My husband's playing some piano tonight. I'm going to do some Friday paper questions from Friday paper number 8, which is due actually this Thursday, October 8th. Okay, so first I'm going to do number 4, division problem. I'm going to do the box because some of you really like that. All right. Let's make it that one. Box and a box. Okay. 1, 2, 3, 4. 1, 2, 3, 4. And my divisor is 0.0066. 0.294 is my dividend. First thing I need to do is make my divisor into a whole number. And I do that by multiplying by powers of 10. Okay. So I've taken 66, let's see, tenths, hundredths, thousandths, 10,000ths. And then I've put the decimal point here to make it a whole number, 66. But I got to multiply it by the same powers of 10, which is 4 powers of 10, which is 10 to the 4th power. 1, 2, 3, 4. So I actually need here another box. My decimal is going to go here and we're going to pop it up. Okay. Now, 66 does not go into 0. 0 times 66 is 66. And 0 minus 66, that's negative 66. What did I do wrong? Oh, okay, Mrs. Golding, it must be late. Let's erase this. 0 times 66 is not 66. That would be times 1. Instead, 0 times 66 is 0. Okay, we could pop this up, but we don't really need it. 66 goes into 2 0 times. Now we can pop up the 2. 0 goes into 29 0 times. So we got 29. Now we've got to pop all of this up. We've never done one like that before. 294. So we have to figure out how many times 66 goes into 294. 294 is almost 300. 66 is, how many times? Well, let's make it 60 just for the fun of it. 60 times 5 is 300. Let's just see what 66 times 5 is. 33, so 330. It's too big. So we think it's probably going to be 4. 26, 264. So that's good. So 4 times 66 is 264. 0, 30. Okay. There's nothing up here. So we have to pop that 30 up. Okay. Now, 66 does not go into 30. So 0 times, okay, so now we have 30 left over, right? And we have here, you know what? I forgot. When you have to add a box, you have to add a 0 when you add a box. So let's try this again. 66 does go into 300. How many times? Not 5, but 4, right? So 4 times 66 is 264. See how I made that into a 6? That was pretty good. Okay, so now let's subtract. However you like to do that. 10 minus 4 is 6. 9 minus 6 is 3. Now we pop 36 up here. 66 goes into 360. Let's make sure what 66 times 6 is. 396. Too big. So 5 times 66 is 330 with 30 left over. I'm seeing something happening here. Another box. Add a 0. Pop this up. We get 300. 66 goes into 300 4 times. And 4 times 66 is 264. I have deja vu because I just did this, right? Now I'm going to pop this back up, but do you see what's going to happen? This is interesting because the 5 and the 4 are actually going to keep repeating. So it's going to be 44.54, 54, 54, 54, 54. So when two digits repeat, you have to put that bar over both of those digits. So my answer for this problem is 44.54 repeating, and make sure your bar goes over both of those. Okay, let's do the next two problems. So 5 and 6. We're going to take this number that's written in scientific notation and we're going to convert it to standard form. That means we're going to get rid of this stuff. Okay, so in order to do that, okay, we're going to write the number down here as it is. But do you see, oops, I need to change where I wrote my number because I need room on the left, and I'll show you what I mean. Boop, boop. Let's put him over here. Okay, when he is multiplied by a negative power of 10, we're actually going to make this number smaller, right? So we have to move the decimal to the left. 1, 2, 3, 4, 5. How did I determine 5? Because of that right there. Okay, so these become zeros. And my answer is 0.00000672. That's a tiny number, right? Okay, good. So now we have this big number for number 6. And we need to take that number, and I'm going to rewrite it down here. 854,300,000,000. Let's see, what is that number? Let's see, 1,000, a million, a billion, a trillion. 854,300,000,000,000. That's a lot. Okay, so we need to make that smaller. So remember, the first step is to find a spot in this giant number that we can plop a decimal point where we get a number in that is between 1 and 10. Okay, so the number, if I put my decimal right here, 8 and 543, let's see, tenths, hundredths, thousandths, that's going to be between 1 and 10. How many places did I have to move my decimal from here to here? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So my answer is 8.543. Those are all significant digits. That means they are important. Times 10 to the how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now it's positive 11 because that's a really big number, right? Okay, let's do the next one. Choop. Evaluate the expressions below. Write your answer in scientific notation. Okay, we haven't learned this yet, so this is going to be important. What are we doing with these two numbers here? So we've got this number and we got this number. They're right next to each other, so that means we're multiplying them. So this is like this rule right here. When we're multiplying a monomial, which is one of the rules that's important in this, you have this one, x to the a times x to the b. We add a and b, right? Okay, so first thing we do, we're going to multiply these two numbers together. So let's see, 6.2 times 2.8, 1649.4. I hope you're showing this work on your paper. Don't just write the answer or you won't get full credit. 9, 10, 11, 12, 13, 4, 5, 6, 7. Okay. Decimal point over 2. Okay, so I know I have 70. Ooh, I can't write that, can I? Something's wrong. 17.36. I'll tell you what I mean in just a second. I'm going to get rid of that. Times 10 to the 5 plus 3, 10 to the 8. Okay, here's the trick. This is not in scientific notation because 17 is bigger than what? Bigger than 10. So I need to do a little finagling here. I need to move this decimal one place that way. So I'm really making this number 10 times smaller, not 10 times, 1 power of 10 smaller. So when I do that, that means I need to increase this one. So I had to make this number smaller, but I need to multiply it by another power of 10 to get it back up to where it needs to be. So that's going to end up making this a 9. All right. I know this is confusing. It's okay. So we got 1.736 times 10 to the 9th. Okay, that's in scientific notation. Okay, so this one, number 8, when you're adding, so we're adding here, okay, with scientific notation, the powers of 10 must be equal, and they're not right now, okay? This one's to the 4th power, this one's to the 5th power. So we either have to bump this one up or bump this one down. But when we do that, we have to change where the decimal point is here to remain equal. Okay, so here's what I mean. Let's say we're going to bump this up to 10 to the 5th power. Okay, so what we need to do is bump this one down. So my decimal needs to go here, 0.801 times 10 to the 5th is going to be equal to 8.01 times 10 to the 4th. This one got bigger, this one got smaller, so we remained equal. Plus 2.4 times 10 to the 5th. Now we are going to have to just add these. So we line up our decimals, 0.801. You could put another 0 here if you want to. And 2.4. You can put zeros here if you want to. 1, 0, 12, 3. Okay, that's in a good spot because that 3 is between 1 and 10. 3 and 201 thousandths times 10 to the what power? To the 5th. This is a preview of what we're going to be doing when we get back from fall break. So that was just kind of a preview. Okay, so we're going to compare for number 5, this number to this number. So you can either make this scientific notation or make this in standard form, and I'm going to choose to put this in standard form. So 3.4, and I need to move it 5 powers of 10. 1, 2, 3, 4, 5. I'm going to add my zeros. What is that number? 340,000. How does it compare to 280? Is that million? Let's see. Boom, 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 boom. Let's see. 100,000. Yeah, 280 million. Well, it is definitely smaller, right? So it is less than, okay? Let's finish up here. We're going to simplify these two radicals. So remember, this symbol is the radical sign. And what we can do here with this radical is we can change this to the square root of 64 over the square root of 81. That's equivalent, and that's okay. Sometimes it's easier to look at it like this. The square root of 64 means we have to find two numbers multiplied by itself that equals 64. That would be 8. Two numbers multiplied by itself that equal 81, 9. But don't forget, it's positive or negative. So plus or minus 8/9. Okay? Because isn't it true that negative 8 times negative 8 is 64? And negative 9 times negative 9 is 81. So we have to account for both of those. If you don't put this, you're not going to get full credit. Okay, number 13. Last problem I'm going to do, we're going to estimate what the square root of 54 is nearest to the nearest whole number. So I like to plop it down here, and I'm going to try to think of perfect squares that lie on either side of it, because 54 is not a perfect square. In other words, if I built a square, right, where each side is equivalent and the area is 54, there's nothing I can multiply by itself to get 54. But it's pretty darn close to 64, isn't it? The square root of 64. That would be a square here that is 8 by 8, right? And then what's on the other side of that? It would be a square. I should make it smaller. 7 by 7, isn't it? 49. So this one lies somewhere in between those. So this is the square root of 49. Okay, but those aren't whole numbers. Those are radicals. So is it closer to 49 or is it closer to 64? Let's see, 49, 50, 51, 52, 53, 54. It's 5 away from there. And it's 10 away from there, right? So it's definitely closer to the square root of 49. So what is the square root of 49? We wrote it right here, 7. So to the nearest whole number, we can estimate the square root of 54 to be 7. It's probably 7.359621978. I'm just making this up. But it's going to be a decimal that goes on forever and ever and never repeats. It's irrational. And sometimes I am irrational in my thoughts. So before it gets too late at night, I'm going to stop and tell you, have a wonderful day.